This section describes how profiling happens in AudioWeaver. Let's start by looking at what happens in a single-threaded application. So this would be a typical embedded target. What's usually happening is there's audio I/O in the background using DMA. When the audio I/O has finished, there's a DMA interrupt, and then the DMA interrupt essentially calls the audio processing thread. AudioWeaver processes the audio. When it's done, it goes into an idle state, waiting for the next DMA interrupt. We jump to the DMA handler, and so forth, and then this repeats. In AudioWeaver, we measure two things. How much elapsed time from the start of the processing block until the next time we start the processing. We call this total ticks per block process available. You can think about this essentially as what's the block rate in the system. The other thing we measure is how long does it take when we start processing until we're done. That's the ticks per block process use. And we leverage system resources like a cycle counter on the target to make those measurements. Let's switch over to AudioWeaver Designer and profile a system. So to profile a system, you have to be running in real time. So here I'm connected to a target. I have the system built and running. And the first thing I'm going to do is I'm going to switch to the server. And the server shows you aggregate profiling information. It shows you percentage of CPU used, and it shows how much memory is used from each of the 3 heaps. If you want detailed profiling information, you can get that from Designer. Go to the Tools menu, select Profile Running Layout, and then Profile block by block. This goes through your design, and it measures number of clock cycles used for each module, and then amount of memory used by each module as well. So you can view the information here, or you can export it to a file. This will save it to a CSV file, and then it'll open it up outside by default using Excel. And here you have the detailed profiling information, and then you can view this or manipulate it. The information on top is also very important. Let's look at this in detail. The first number, total ticks per block process available, essentially is the number of profiling clock ticks elapsed between pump calls. So on the system that we're running, we have a 48 kilohertz sample rate, a 480 sample block size, that is it's 10 milliseconds. The processor speed is 480 megahertz. So in a 10 millisecond time interval, there are 4.8 million clock ticks. And so the number that you see on top should be very close to 4.8 million, and indeed it is, 4.02 million clock cycles. Let's look at the other numbers. Average ticks per block, that's the average processing load. Every time a module is executed, we measure this elapsed cycles, and it goes through a first order smoother. We also show the instantaneous ticks, that's for the last block that was processed. And then we also show the peak ticks per block. This is the highest number that was ever recorded. And you can see something's not quite right with this design, because we're going from 21% up to 31%. Let's look at this a little more closely. Going back to Designer, we're going to do the second type of profiling, which is the peak profiling. And I'm going to type in profile for 20 seconds. And what it does is every half second is it measures the average CPU load, the peak CPU load seen in that half second, and then it repeats. So this goes on for 20 seconds. And ideally, you should see a perfectly flat CPU load. And here we see peaks jumping up and down. And it turns out that in this BSP, there's sample rate converters inside the BSP that are also taking additional time. So we're seeing fluctuations in the CPU load. So this is the second kind of profiling feature we have available in AudioWeaver, peak profiling.